Om Swastiastu. Hello everyone. My name is Putu Paramitha Manik Valery with number 201-301-1065. I'm from class 4A. Today I want to explain about how to solving system of linear equation using determinant. Before we solving the system of linear equation, we have to know about what is a determinant. A square array of number or variable enclosed between vertical line is called determinant. Determinant is a value that is obtained from square matrix. In this video, we just talking about two types square matrix. They are 2 by 2 matrix and 3 by 3 matrix. Because that matrix is related with system of linear equation, including 2 variable and 3 variable. Determinant of 2 by 2 matrix. The following determinant has 2 rows and 2 columns is called 2 by 2 determinant. If A, B, C, and D for real number and we have matrix A, we can write the determinant of matrix A like this picture on the right side. A, C, B, D written between vertical lines. To check out the value of 2 by 2 determinants, we just have to finding result of the subtraction of the diagonally down product minus diagonally up product. To find the determinant of A, C, B, D, we have calculated value of A times D minus B times C. For example, find the value of determinant 3, -11, 7, 2. It equals to 3 times 2 minus 7 times -11 equals to 6 minus -77 is 83. So, the value of determinant from 3, -11, 7, and 2 is 83. And next, we will talking about how to solving system of linear equation including 2 variable using determinant. Finding the solution of system linear equation using determinant is referred to as Cramer's rule. Here, we have system of linear equation with 2 equation and 2 variable. To find the value of x, we use formula x equals to dx divided by d, and the value of y equals to dy divided by d. So, we have to create 3 types of determinants. They are d or denominator determinant, dx or determinant of x, and dy determinant of y. D is formed by taking a coefficient of x and y from the equations. In this case, D is determinant of A, B, C, and D. Dx or determinant of x is formed by taking the constant terms from the system and placing them in the x coefficient positions. In this case, the x is determinant of S, B, T, D, because we are replacing A and C with S and T. Dy or determinant of y is formed by taking the constant terms from the system and placing them in the y coefficient positions. In this case, dy is determinant of A, S, C, and T, because we are replacing B and D with S and T. For example, use Cramer's rule to solve this system. 4x plus 6y is 3, and 8x minus 3y is 1. The answer is, first, we have to find out the value of d, dx, and dy. D is determinant of coefficient x and coefficient y, so D is determinant of 4, 6, 8 and negative 3. Equals to 4 times negative 3 is negative 12 minus 6 times 8 is 48 equals to negative 60. Dx is determinant of replacing coefficient x, 4 and 8 with constant terms 3 and 1. So dx is determinant of 3, 6, 1 and negative 3 equals to 3 times negative 3 is negative 9 minus 6 times 1 is 6, so negative 9 minus 6 equals to negative 15. dy is determinant of replacing coefficient y, 6 and negative 3 with constant term 3 and 1. So dy is determinant of 4, 3, 8 and 1 equals to 4 times 1 is 4 minus 8 times 3 is 24. So 4 minus 24 equals to negative 20. X equal to dx divided by d is negative 15 divided by negative 60 is equals to 1/4, and y equals to dy divided by d is negative 20 divided by negative 60 equals to 1/3. Next is determinant of 3 by 3 matrix. We can define the determinant of this matrix. We choose entries of first column or first row and multiply it with their minor determinant. Here we choose entries of first column, which are A1, A2 and A3. First entry we give sign positive, second entry is negative, and third entry is positive. Because we choose entries in first column, each minor determinant is obtained by crossing out the first column and one row. For A1, the minor determinant is crossing out the first column and first row. For the A2, the minor determinant is crossing out the first column and second row. For A3, the minor determinant is crossing out the first column and third row. So, the determinant of this matrix equals to A1 times determinant of B2, C2, B3 and C3. Subtract because its sign is negative. A2 times determinant of B1, C1, B3 and C3. Add because its sign is positive. A3 times determinant of B1, C1, B2 and C2. Next, for example, evaluate the following determinant: negative 2, 4, 1, negative 3, 6, negative 2, 4, 0, 5. The answer: first, finding the minor determinant, negative 2 times determinant of 6, negative 2, 0, 5. Subtract negative 3 times determinant of 4, 1, 0, 5. Add 4 times determinant of 4, 1, 6, negative 2. Then we calculate it and get solution is negative 56. Number 2 is solving system of linear equation with 3 variables using determinant. To solve system of linear equation including 3 equation and 3 variable, it's really similar way with solving system equation including 2 variable. But we just need to find one more determinant, which is the determinant of z, with replacing the coefficient of z with constant value. So we will have 3 solutions, which are x equals to dx divided by d, y equals to dy divided by d, and z equals to dz divided by d. And d, or denominator determinant, is not equals to 0. The first step, we have to find out the value of d, or denominator determinant. Is the determinant of x coefficient, y coefficient, and z coefficient. For example, solve this system of linear equation using Cramer's rule. Here we have system with 3 equations and 3 variables. The first step, we have to find out the value of d, or denominator determinant. D is the determinant of x coefficient, y coefficient, and z coefficient. So we got determinant d is determinant of 3, 2, negative 1, 2, negative 1, negative 3, and 1, 3, negative 2. Now look at the entries of first column. We will multiply it with their minor determinant, and don't forget about the sign. Positive for the first entries, for the second entry is negative, and positive for the third entry. Okay, determinant d equals to 3 times the minor determinant of entries by crossing out the first column and first row. So 3 times minor determinant of negative 1, negative 3, 3, and negative 2. And subtract, because the second entry is negative, so subtract 2 times minor determinant of entries by crossing out the entries if the first of the first column and second row. So 2 times determinant of 2, negative 1, 3, and negative 2. Add, because positive sign for third entry, so add 1 times the minor determinant of entry by crossing out the first column and third row, and we got 1 times determinant of 2, negative 1, negative 1, negative 3. It equals to 3 times negative 1 times negative 2 is 2, minus 3 times negative 3 is 9, so we have 3 times 2 minus negative 9, minus 2 times 2 times negative 2 is 4, minus 3 times negative 1 is negative 3, so we have 2 times 4 minus negative 3, plus 1 times 2 times negative 3 is negative 6, minus negative 1 times negative 1 is negative 1, so we have 1 times negative 6 minus 1 equals to 3 times 11 minus 2 times negative 1 plus 1 times negative 7 equals to 33 plus 2 minus 7 is 28. So the determinant d is 28. Next, we will find out the value of determinant of x, determinant of y, and determinant of z. For determinant of x, we replace the entries of first column which contain x coefficient with constants, so dx is determinant of 2 to negative 1, 13, negative 1, negative 3, 1, 3, and negative 2. For determinant of y, we replace the entries of second column which contains y coefficient with constants. So dy is determinant of 3 to -1 to 13, -3, 1, 1, and -2. For determinant of z, we replace the entries of third column, which contains z coefficient, with constants. So dz is determinant of 3 to 2 to -1, 13, 1, 3, and 1. With the same step as before, then we get the value of dx is 28, dy is -56, and dz is -84. Therefore, we can calculate the value of x is dx divided by d equals 28 divided by 28 is 1. The value of y is dy divided by d equals to -65 divided by 28 is -2. And the value of z is dz divided by d equals to -84 divided by 28 is -3. So the solution is x equals to 1, y equals to -2, and z equals to -3. Cramer's rule with inconsistent or dependent system. If d equals to 0 and at least one of determinants dx, dy, or dz is different from 0, then the system is inconsistent and the solution set is empty set. If d equals to 0 and all the determinants dx, dy, and dz equals to 0, then the system is inconsistent and dependent. So there are infinitely many solutions. The system must be solved using row reduction technique. Okay, thanks for watching my video. I hope my video could help you to learn about solve system of linear equation with determinant. See you. Om Santi 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 Om.